Okay, I can do this. Sweet. Okay, so probably should have left that in the camper. Off to get some battery stuff. So I just got to Napa Auto Parts. I'm here to get some wires to wire up my batteries to make the battery module. I'm thinking I need 14 or 15 AWG wire, 14, 15 gauge. Should be able to handle the current I need. It's going to be around 20 amps. So as long as if I get something that can handle up to 30, it should be fine. Gotta find the wire. Sorry to interrupt you. I guess. Yeah. Oh, there it is. Perfect. Thank you for the help, Mace. I appreciate your help. Okay. 12 gauge should definitely be plenty. Probably just gonna go with black. I don't feel like buying two different color wires. I can use tape to identify which one's hot and which one's not. Now I gotta get the connecting bits to put them together. See, I don't remember what size the nut and bolts are. Oh wait, they're in the car. I'll be right back. They're tiny. Super small. I bring one inside. Okay. Alrighty. Now we're just gonna eyeball it. Oh yeah, that would definitely fit. That might be a little too big. Not sure if too small. I think that would fit well. Are those crimpable? Yeah, of course they are. We'll see if I can open it without breaking anything. Heck yeah, it fits. These are perfect. Here we are. Should be plenty. Like $10. Hey friends, so today I'm going to be working on the battery. It's the same day as me painting my bike, but I don't want to hang out in the camper and get high as a kite, so I'm gonna build a battery in my car, which is right here. I'm guessing this is the right direction. I can't see what I'm doing when I'm wearing these glasses. These are electronics glasses, sort of. They're used for wiring, like soldering circuits and stuff. Are they necessary? No. Do they make me feel smarter? Yeah, they do. So I'm gonna wear them. So, these are my batteries. These are what I'm going to be using to make a battery module. Each of these is 12 volts, and I need to wire them in series. That way I get 48 volts in total, so it'll add up each voltage. The amperage will stay the same, but the voltage will increase, which is nice, because then I can actually run my motor for these cheap batteries that I got off of Amazon for like 20 bucks each. The first thing we're going to do when assembling a battery pack, or a battery module, I feel like that's the appropriate term, is we need to make sure that each of the cells is the right voltage. So what that means is if you have a bunch of buckets that you're filling with water, what we're doing is to make sure that all the buckets start at the same level of water, if that makes sense. Because if we're filling up the buckets, charging them, if one's already full, but another one's not, and we continue to fill them all up at the same time, the full one is going to start overflowing. So that's kind of what happens with lithium-ion batteries. So with the Galaxy Note 8, the cell phone, if you overcharge them, they'll expand. They'll try to pop because they're getting too full. Kind of like a water balloon. If you fill a water balloon up too much, it'll... So we don't want that to happen. I'm using lead-acid batteries, so it's not an issue. Lead-acid batteries emit a gas when you overcharge them too much. So it's not too much of a big deal. They're a bit more pliable. They're flexible when it comes to overcharging. But I'd still rather not do that if I don't have to. They've been sitting in a cold car, and temperature affects lead-acid batteries. That's why if you lead acid is what you use in your car most of the time. So if your car might go dead in the winter if you don't run it for a while and it sits out in the cold, it'll discharge itself. So since they've been sitting in my car, I want to make sure they're at the right point before I plug them up all together. This is a multimeter. A multimeter is a tool used to check amperage, voltage, and resistance in a circuit. So what we're going to be checking today is voltage. These are 12-volt batteries. They're lead acid, and we want to make sure that each of these batteries is at least 12 volts and preferably equal voltage. So we're going to hook up each one of these to the multimeter and see what it says. First thing I'm going to do is turn it on, and we're measuring voltage in DC current. So we're going to go to the DC setting and we're going to measure the voltage. Now these should be 12 volts, so we're going to turn it on to a maximum of 20. Cool. We are over 12. 12.96. 12.91. Went up to 12.93, I think. Yep. Camera, where are you going? Where are you going, homie? Okay. 12.99. Oh man, it's all, yep, 12.99. Awesome. All over 12 volts. They should be good to go. So the next thing we got to do is wire them up in series. So series is positive to negative. So we're going to go positive to negative, positive to negative, positive, negative. Something you could do is add spacers in between these and such. That way you prevent short circuiting. Like if you dropped a crowbar or a wrench or something metal across each of these, you wouldn't short it out. But I'm not remotely concerned with that. So time to make the wires. We have our braided wire from yesterday and the connectors. So we're going to cut them to length, attach the connectors with all of these fun gizmos, and get
Drive highways and byways, be there with you, over and over, the only truth.
Wait, are these threaded? Did I get the wrong ones? God dang it. I got the wrong ones. You don't crimp these. God dang it. These are threaded. I'm frustrated. What's up, guys? I made it back. I was able to acquire some crimpable attachments for the wires I made. Hopefully they work. If they don't, I'm just screwed. I'm straight out of luck. It's snowing right now, still. It's been snowing for hours and hours and hours. So obviously the roads aren't too great. And I'm driving a very tiny car. And I live up in the mountains. So it was an adventure trying to get down the mountain to get these and get back. I drove into a ditch, slid down a hill, and a dude's truck drove into me, but we're good. We're good. I got what I needed. Alright, now the battery is wired in series from positive to negative, positive, negative, positive, and negative. What this does is it gives it one path for the current to flow inside of the battery. So that means all of their voltages will be added together. Like all of the force that each battery provides is all going to go down the same pipe. So it all adds together. Which means if I did it right, it should come out to be over 48 volts. Perfect, 51.8. I was expecting 52. That's awesome. So, the battery is completely finished. So, what I have hooked up is I put a new seat on, and I have this little bike rack, and I ended up using these straps. The strings worked pretty well for a while, but I was more comfortable with these because, you know, they're not ratcheting, but they're nice. And I cut them and melted these in, so they're nice and not frayed. And I have the charger hooked up right now. It's completely charged. This is a 48 volt charger for sealed lead acids, so it's exactly what this module is. And yeah, it works pretty well. Let's hook it up and give it a test drive.
Something like 6 1,